Hi, everybody. Welcome back. We're going to continue our exploration of vertex form of the quadratic equation. As a quick little reminder, I want you to know that there are three forms of the quadratic equation. First one is the factored form, which we looked at initially. And it was nice because it gives us the x-intercept. Gives. But we got to remember to change the signs. Right? So if we had a x plus 7, then the intercept was minus 7. Second one is standard form. This is the, I don't know, it's just like the in general style. Really isn't a whole lot of use to us, although it does give us the y-intercept without a whole lot of muss or fuss. And then finally, of course, there is the vertex form, which we're looking at today. We've looked at A already. It controls up or down, stretch, and compress. Most basic quadratics, y equals x squared. You're going to hear me call this the standard. You're going to hear me call it the king parab because I like it as a king. And the vertex is at 0, 0. So our goal today is going to be to move that vertex somewhere else. So using Desmos or whatever graphing software you're using, make the vertex move down. Make the vertex move up. What you are looking at is the properties of k. If k is negative, the vertex is going to move down. If k is positive, then the vertex moves up. Okay, this time we're going to try and get you to move the vertex left or right. And this is a little bit more challenging. In order to do it with precision and exact match, we have to put the value inside brackets. Some of you might have played with the b value in standard form, but you'll notice that it wasn't a one-to-one relationship, whereas here in factored form, it is. Now, if h is negative, then the vertex moves to the left. If h is positive, the vertex moves to the right. Now, this is a little confusing because we're just talking about h. When we're bringing it out of the equation, we have to change the sign. So it does kind of, what I've written is technically correct, assuming we're looking at h only. As soon as we take into account what the point is going to look like, we have to change that sign. So it's very much like factored form. So it's like the factored form and those darn x-intercepts. So putting it all together, A controls whether it opens up or down, right? If it's positive, it's up. If it's negative, it's down. It controls the compression or stretch. So if it's larger than 1, it's stretched. If it's between 1 and 0, then it's compressed. I'm ignoring signs. So if it's a negative 0.5, that's still between 1 and 0, it'll be compressed. Horizontal displacement is controlled by h, so that moves things left and right. And k controls the vertical compression, up and down. Start with a base function of y equals x squared, state the formula, and draw how the parabola is moved. So if we're looking at 3 units to the right, that means physically we're moving 3 units to the right. The equation becomes, now you don't actually have to put a equals 1, minus 3. Right? We got to change that sign. So 3 to the right is positive 3. When we put it in the equation, it becomes a -3. This is what I'm saying. It's a little confusing. If we're going to go 2 units up and 4 to the left. So now our vertex is here. We still have no stretch or compression. -4, so that becomes a +4. And outside the brackets is exactly what it was before. And of course, oops, come on. There we go. The graph itself. So that's the gist of it. We're going to focus on the moving things left to the right. We're not going to deal with A an awful lot. Tomorrow's lesson will tie everything together, so we will end up practicing it some more. Hopefully you get the idea today. Tomorrow we will focus on cementing it in place. All right, guys, have yourself a good one.